So here are practice problems. So again, every single line in this on this page is tangent to the circle if it appears to be tangent. So looking at question 1, immediately we know that since these are tangent, they both have to be perpendicular to the radius. Okay, so again, sum of angles in the quadrilateral is 360. We can write an equation: 3x plus 2x is 5x, plus the two 90-degree angles, so 180 equals 360, which means that 5x is equal to 180 and x is equal to 36. Okay. Question 2. Same deal. We know that this has to be a right angle, okay, which makes this a right triangle. And in a right triangle, the two acute angles, which are marked right here, are complementary, which means their sum is 90. So we can write 4x plus 4 plus 8x plus 2 equals 90. And that gives us that 12x plus 6 equals 90. 12x is equal to 84, and 84 divided by 12 is 7. Okay. Once again, we have two tangent segments. We know that those two segments have to be congruent because they meet in the same point. So we know that 2x minus 4 is equal to x plus 7. If we get x's to the left and the constants to the other side, we get that x is 11. Now the question here is find the radius. And the radius is equal x minus 2, which is 9. Okay. Again, this is a quadrilateral, right? We see all of these segments are tangent because none of them intersects the circle at more than one point. So we know that the segments that meet at the same vertex have to have equal length. So if this is 3, this one is 3. If this is 5, this has to be 5. If this is 2, this is 2. And if this is 7, then this one is 7. And then finding perimeter is just adding them all around. So 3 plus 5 plus 5 plus 2 plus 2 plus 7 plus 7. So perimeter is equal to 6, 16, 20, 34. Okay. Here in question 5, we are asked to find the area of triangle ABC. So obviously we know this is again a right triangle. Okay. Both of these are radii, so they both have to be 4. So now we need to find the length of this base, because remember that altitude has to be perpendicular to the base. So we are going to call this x. We're going to call this x, and then we're going to use the Pythagorean theorem to find x. So we know that 4 squared plus x squared has to equal 4 plus 5 is 9 squared. Okay, so 16 plus x squared equals 81. X squared is equal to 81 minus 16, which is 65. So x is equal to square root of 65. So now the area of this triangle is going to be 1/2 times the base, which is square root of 65, times the radius, which is, the height of this triangle, which is 4. So that gives us that area is equal to 2 square roots of 65. Okay, and here's the last question. Again, remember that this is perpendicular. Okay, if this is 9, that's our radius, then this is also 9. Okay, so again, we can use the Pythagorean theorem. Okay, a squared plus b squared. So 9 squared plus x plus 5 squared is equal to this hypotenuse, which is x plus 8, because we have to subtract 1 from 9 squared. Okay, we're going to expand both sides. So x squared plus 10x plus 25 is equal to x squared plus 16x plus 64. Okay, so x squared and x squared cancel, combine like terms. So 10x plus 106 equals 16x plus 64. Get all the x's to one side, so 6x is equal to 106 minus 64, which is 42. And that means that x is equal to 7. And there you have it. I hope everybody gets how to do it. If not, remember you can always text me on Remind. Okay? See you.